In this lecture, we'll discuss counting problems in geometry. So for example, we're going to look at this question, how many squares are there in this picture? Before we start, let's again start with a warm-up problem. Let's look at this graph. Okay, so the question is, in this graph, how many rectangles are there? All right, you're ready to give an answer? So how many rectangles are there? Well, as any counting problem, we should count in some organized way. So let's count according to the size of the rectangle. And we have some small rectangles. And how many are there? So size, let's call size 1 rectangles. Like these ones. This guy is size 1. Okay, so how many are there? There's 1, 2, 3, 4. We have for size 1. And then next we count the bigger size. Let's call size 2. So what are the stuff that has size 2? Well, these contain 2 rectangles. For example, 2 size 1s. And these 2 together will be size 2. And how many are there? Well, going vertical, we have 2. Horizontal, we have 2. So 2 plus 2 is 4. And do we have any size 3? Well, in order to be size 3, it has to somehow be an L shape, like 1, 2, 3, like this. But that's not a rectangle, so there's nothing of size 3. And finally, there's this big rectangle of size 4. And so total will be 9. Alright, so did you get that? And if answer is 9, it's correct. But if you tell me the answer is 0, then I won't be too happy because that will be your complaining about my drawing here. You're just saying I'm not drawing straight lines. Okay, so now let's get back to the problem. Now let's look at this question. How many squares are there in this picture? And we'll do this problem again by counting by the size. So let's first look at the number of size 1 squares. And how many are there? Well, in this case, we can look at the picture and say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for each row. And there are how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is indeed a 10 by 10 square. So we have 10 by 10 size 1 squares, which means it's 10 by 10 is 100. Okay, next let's count how many size 2 squares. And this is not as straightforward. Let's look at size 2 square here. These are 2 by 2 really. So instead of writing size 2, I would say size 2 by 2 squares, and this is 1 by 1 squares, and then we'll have 3 by 3, 4 by 4. And there are quite a lot 2 by 2 squares. And how do we count them all in an organized way? I mean, some of the squares do, for example, this square and that square, they have some squares that's shared. So it becomes a question, how do we count in an organized way? And here the key trick is, instead of counting the square itself, we'll count the vertex of a square. And in particular, what we're going to count is this point, the lower left corner of the square. And basically, you fix the lower left corner. Let's say you fix the lower left corner here, and then actually fix the square. Because if the lower left corner is here, then your square is this 2 by 2 square. So each square corresponding to a lower left corner, and we just need to count how many lower left corners there are. And how many are there? Well, virtually every point can become a lower left corner. And pick any point. Except if it gets close to the right. Like this doesn't work. This point doesn't work. Because this point is for its square, you have to go outside. That doesn't work. So basically, you cannot go to this column. And you cannot also go 2 up. If you come here, like this point doesn't work. Right? Anything here doesn't work because it goes up, it's outside the picture. So anything below this line, the second line, and anything to the left of this line, the points here can be lower left corner. And how many are there? Well, that's easy to count. 1, 2, 3, 4, 5, 6, 7, 8, 9 for this row. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 times 9. And so indeed we'll have 9 times 9 size 2 by 2 squares. And we know what 9 times 9 is, but I will write it as the power of 9 squared. This is 10 squared, because then we see the pattern. And if you look at size 3 by 3 squares, and you have 8 times 8. Basically, there will be pattern 10, 9, 8, 8 squared. And that's because, again, for 3 by 3s, again, you will look at, given any lower left corner, you fix the 3 by 3. This will be 3 by 3 corresponding to this particular lower left corner. And you do the same discussion we did. And any 3 by 3 will have lower left corner start below this line and to the left of this line. Okay? And similarly, you can work for 4 by 4. Okay, so I think I will just use dot dot dot, and I think you guys can convince yourself. And in the end, the last one is the size 10 by 10. And just as we expect, it become 1. And 1 is 1 times 1. There will be 1 size 10 by 10 squared, 1 squared. So the answer to this problem is that you have this sum. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Okay, now what is this total? And this sum, there is a formula to calculate easily, but it's not as simple as just adding 1 plus 2 plus 3 plus 4. You cannot just do the trick, say put a 10 square here, this trick, and 10 square plus 9 square. This trick does not work. So for the moment, let's not use any tricks, just calculate with brute force and do the mental math. 1 plus 4 equals 5. Plus 9, 14. 16, that's 30. 25 becomes 55. 36, that's a 91. 49, 140. 64, 204. 285, and that's the answer. Okay, so this is the discussion for how many squares in this picture. Okay. Next, we'll look at some other examples of counting in geometry and some more examples.